Uh, Good day, everybody. Thanks for joining us again for this continuing series on data science and society. Today, we're very lucky and very happy to have some good friends from across on the other side of the globe in Singapore, being the AI Singapore folks. We're being joined by Jian Gang and William Tjhi from AI Singapore, and they will be giving a talk on development of a sea lion, which is the kind of a regional Southeast Asian large language model. This is important, not just I think for us. I think it's important for the globe, for as many people who are trying to work out and building these systems to understand what it takes, what the learning processes were, what worked, what didn't work, and then some of the advice on how we should kind of think about this going into the future. Just for context, for people who are joining for the first time, so we run at Data Science for Social Impact, and now also with the African Institute for Data Science and AI, yearly a seminar series. Last year, the big themes were around language, around health and medicine. And this year, the big change is really going back to our roots in natural language processing. So we're very happy to have the AI Singapore folks, and we are also on a process for this year in building a Pan-African LLM. A number of the team is also on this call. A number of people who are also trying to build language models, not just necessarily LLMs, are here, and lots of people are also interested in what some of the stuff that's going on. Just for noting, these sessions are recorded. We will cut them to mostly focus on the presentation, and after there'll be about 40 minutes of talk from the presenters, and then after that we can go into Q&A. Please do feel free to also use the chat if you're not going to be able to unmute to ask your question. And then from there, yes, today is a kind of longer typical Q&A session. We made it also 40 minutes just because we do expect that there's going to be a lot of questions. So with that, I will hand over to Jian Gang and William.
Maybe I start first. I just want to say that we are very honored to be invited and to share our story to this group. And because he's a great friend, and I think we see him as our partners, from the other side of the globe. And we hope to work more closely with him. And I think hopefully that this is going to be the first among many of our conversations with this group over here. Maybe I do a quick round of introduction. Jian Gang will do it as well. And then after that, I'll give a brief introduction of our organization before Jian Gang walk us through the development of the sea lion itself. My name is William. I'm the deputy director of one of the divisions in AI Singapore, the AI products. Both Jian Gang and myself are from the same division. In the past, the two of us, we led the development of the sea lion open large language models themselves. Both the models, the data, and also the evaluation. But I think since about 6 months ago, we kind of have to divide and conquer. So Jian Gang continues building the LLMs and the evaluations, whereas myself, I need to move into diffusing some of the knowledge and technologies that we have into applications, right? Healthcare and education and so on. So we are still in the same team. So Jian Gang, why don't you introduce yourself?
Hello, everybody. Just as William said, we are very happy to be here. It's really our great pleasure to be able to share some of our work with the team here. I am currently heading the model development team, the evaluation team, as well as a small research team. So the Sea Lion family of models is one of the main projects of our division here in AI Singapore. But besides that, and I'll also be talking about this in the slides, we also have the SEA-HELM evaluation suite that was done in collaboration with the Stanford HELM team. And this is something that is still ongoing. It's part of our efforts to really have open source models, open source data, and transparent evaluations for these models, right? And also, of course, the research that we put out is also part of this effort to be open and have work that is reproducible and can be shared with other people. So yeah, I'll be happy to talk more about what we're doing later. Back to you, William.
Yeah. So while Chen Kang is preparing his slides, so let me do a bit of introduction of AI Singapore and just to set the context very briefly. So AI Singapore, we are the national program office of the government of Singapore. We are fully funded by the National Research Foundation of the government. Our mandate is to help the nation build healthy AI ecosystem. We've been around since 2017, way before our current generative agentic AI age. And some of the activities that we do, including research, we also build the talent. We work to promote AI adoption in the local ecosystem. We help the government shape the governance, and also we, at the same time, the main topic of today, build open source platforms for the benefit of Singapore, but also the region surrounding it, the Southeast Asia. And one of the open source platforms that we are currently building, of course, for the past 3 years, is the Sea-Lion that you will hear more from Chen Kang. It's an open LLMs that, yes, we build it driven primarily by the team that we are leading, but at the same time, it is an effort. I want to acknowledge first that it's actually a regional effort. So, our neighboring countries have been great, supporting us, Indonesia, Thailand, the Philippines, and so on. So pretty much the whole of Southeast Asia are together with us to co-develop it in some way. And this is an open, non-commercial. We treat this more like a digital public infrastructure. So we're happy to share this, our journey. It's still an ongoing journey, happy to also take on more questions. I'm sure there are similar efforts going on. Some of the things that we have learned will be similar. Some of the things may need to be adapted. I think that's the beauty of the discussions. Chen Kang, go ahead, take it away.
Okay, so I will share. Sorry, I will share my screen now. Can everybody see this? Yes. Okay.
Yes, thank you.
All right. So today I will talk a little bit about a few of the following things. So I'll start with talking about the processing of the pre-training data that goes into Sea-Lion. And this processing is not purely an engineering process. We also involve our human native speakers as well from the various communities around Southeast Asia. And this is an important piece of the work for us because we really want the data to be reflective of the cultures and the languages, right, that we want to cover with Sea-Lion. So we really do put a lot of attention and a lot of effort into trying to weave in the human validation in the data. And then I'll also be talking a little bit about the actual CPT process, right? But again, because we have limited time, so I won't go into too much detail in the slides themselves, but happy to take questions. Another important part that I will be talking about is the evaluation as well. And the evaluation part will feel a bit like we're switching gears, but that's also by design in a sense, because the evaluation component is separate from the Sea-Lion itself, in the sense that we want to have SEA-HELM as a set of benchmarks, right? And an evaluation suite that doesn't only work for Sea-Lion, but can actually serve the Southeast Asian community at large, right? And then the last part, I'll just do a quick intro of our latest release, our Sea-Lion version 4.5, right? And then after that, we'll open the floor to questions. Okay. So again, starting with pre-training, right? Now, there are quite a lot of things to consider when we're talking about the pre-training, right? We have to worry about, because it's an open source data set, right? We have to worry about where we get the data from, right? Even if it's academic sources or government data sets and so on, we have to make sure that the provenance of the data is okay. So this means that, for example, we have to use commercially permissive data sets, but we also have to make sure that the data sets are not copyrighted, right? And then, of course, as I mentioned, because we want Sea-Lion to be able to support multiple languages in the region, especially at least like the major languages or the official languages of Southeast Asia. So we really have to pay attention to the kinds of quality signals that we're getting from the data sets. And this is per language, right? And then we also have to look at optimizing the tokenization process for the Southeast Asian languages, which we usually abbreviate as SEA, right? I'll also be talking a little bit about pre-processing pipeline, some deduplication, not so much. It's just a thing that we have to do, right? And then I'll also give a few examples. You get to take a small peek into the UI that the annotators actually see when they're looking at the raw data and how they use that to help them to annotate and provide some feedback, right? Okay. So this is just kind of like a rough flow of the entire data processing pipeline, right? So it's actually quite involved, and this is just in a way how we have been trying to summarize the entire process. As you can see, there's a lot, right? So we have the text extraction, then we do deduplication, we have to do language detection, we take various snapshots and so on. I would like to bring everybody's attention to the two parts where there are stars. So I think maybe you can see my cursor. So the quality signals and the perplexity thresholds. So those are the parts where we loop in the human annotators a lot more to help the data validation, right? So here actually is the actual UI that the annotators will see, right? So on the right-hand side, you'll see that there are a few toggles, right? So these are values that they can toggle with. And depending on the language, these values look different, right? So for example, with a language like Vietnamese versus say like Thai or Tamil, right? You actually see that maybe the token count per document has to be higher, if only because of the fact that it takes so many more tokens to be able to represent 500 words, right? In say like Tamil as compared to Vietnamese, right? So then of course repetition, this looks at the repetition of certain characters, but again, depending on the grammatical characteristics of that language, you also may have a higher rate of repetition that is acceptable, right? There's a few other things here, special characters, punctuation, and so on. So all of these values, the annotators have to toggle with, and the reason they do that is because they then get to see, right, like given a specific set of values, what gets discarded and what gets retained. And this is what you see on the left-hand side, right? Now, when they see what is retained, they can actually check the quality of what gets retained. So the X there means that actually this should not be retained. And when they check the discarded column, they'll see, oh, actually, this gets discarded, but it shouldn't be so. So then they have to toggle with the values again until it kind of reaches a point where it roughly corresponds to what should get retained, what should get discarded. I hope that makes sense, right? Okay. Here is the other part where they look at whether the data quality has been correctly bucketed. So generally speaking, we have a high quality bucket, a middle quality bucket, and a so-called low quality bucket, right? So that's your head, middle, tail. But that's not to say that the data in the middle quality bucket and the low quality bucket is not useful for training. They are still useful for training, right? It's just that it kind of gets it gets put into different categories because the amount that we want to use in our data mix experiments or for trying to see like which is the optimal data mix for the models to learn from, they differ. Having the quality buckets done this way really helps us to kind of have more variation in the data mix experiments, and we're able to go have a little bit more sophistication, right, in how we approach this optimization process. So what might go into something in the high quality bucket would be, for example, like your news articles from, say, like official news sources, right? Or what might go into your journal articles, right? And then in your middle bucket and in your tail bucket, usually that would be where your blog posts might go, where your forum posts might go, but also that is where a lot of the informal varieties of the languages would fall. So for instance, with Indonesian, you have a formal variety and an informal variety, but both are used, right, by the speakers. In a formal, the formal variety probably used like in a school setting, right? Or when you're talking to your superiors at work, like your boss, your supervisor, right? With the informal variety, actually you use this with friends, with family, in more informal settings, like maybe like over dinner or something like that, right? Which means that you want your model actually to be able to understand both the formal and the informal. So you need to have representation from both of these varieties, or even in languages where it's really just about having like certain colloquial or slang terms, you need your model to still be able to understand that. So it's still important to have some representation from that, and usually these fall in the middle or tail buckets, right? So one thing that we do here is we try to peg the head, middle, tail buckets to a rough perplexity score range. So as an example, you see here, we might say like, okay, does this range work for this language? In this case, it's Vietnamese again, right? Maybe your range of perplexity score for the head bucket might be anywhere from like 100 to 250, perhaps, right? And then the middle is anywhere from like maybe like 260 to 1,000 or so on. And then if these perplexity thresholds don't work, then it can be adjusted, right? So that it roughly corresponds to what the human annotators would say that, yeah, this is actually high quality, this is somewhere in the middle, this is the more low quality data. And of course, sometimes the more low quality data, it really is more low quality in the sense that like, it could be, the content could be, for example, like a bit less informative, right? Or maybe it's like a lot of short forms and so on, but it's still good to be able to index where that data stands. Okay, so this is just kind of the feedback loop that we have, right? So we have these signals and rules, heuristic rules per language, right? Per language that we want to include in our pre-training data. And then, we have the filters and we run some quick experiments. Usually we try to go with like a 10% budget. 10% token budget, sorry. So let's say we are, so for example, for our V4, version 4, we had a total of 500 billion Southeast Asian tokens for continued pre-training. So then a token budget of, let's say, 10% to run your experiments, right? So that'll be 50B, right? But maybe if you want to do something even quicker than that, just to see like roughly whether you've done the quality signals correctly, whether you've done your heuristic rules correctly, you can go maybe even a little bit lower than that. It really depends, right? Okay. These are just some numbers for how we did the data processing, pre-processing, I should say. Note that this is not the model training yet. This is just processing the data. So we're actually looking at using CPU rather than GPU, right? And you can see that actually a lot of time is spent on this. But this is quite an important process before we can actually start the experiments and the training. Okay. Now I will talk a little bit about the CPT itself, what we did for our version 4. So with version 4, we used a total of 256 H200s, right, which is 32 nodes. And like I said, we trained on a budget of 500 billion tokens, right? Took about 86K GPU hours in total. So some of the training techniques, or rather some of the training strategies that we employed, things like data parallelism, model parallelism, FSDP, and so on. These are essentially ways of helping us to mitigate risk, right? So I think I have a slide for that, but if not, I'll talk a little bit more about it later on. Okay, here is just an illustration of how we manage the compute cluster, right? So you have your head node as an orchestrator to kind of like send out the jobs and queue the jobs and so on. We use a Weka file system because this enables us to be able to load in many different types of files. I mentioned just now that we wanted or we want to be able to run data mix experiments, right? So this not only includes having like different types or different types of documents, I should say, per language, but also we need to have different proportions per language. And you might imagine that this would really require us to load in many different files at once. So a Weka file system we found has been pretty flexible for that. Okay, right. So here are just some details on some of the distributed strategies that we have. And the reason we do this is because training a large language model can be quite costly, right? Every hour you're spending quite a lot of money, right? So if let's say you do the training for maybe let's say 10 hours, 20 hours, and then training sometimes does fail, right? So if something happens and you have to resume the training all the way from the start, that's going to result in a lot of resources that are wasted. So what we do is we want to have data sharding. We want to be able to have checkpoints so that after a certain amount of time, you are actually able to, in case of any kind of failures, you're actually able to recover a previous checkpoint from maybe a few hours ago, so you end up losing less of the resources, right? And as I mentioned, this is a critical step in training because it's really about mitigating risks for when training fails, which of course it will happen. And the more you scale up the training process, meaning the more cards you try to use for your model training, the more likely that there's some kind of failure because of internal communication and so on, right? So this is something that's actually very important to work out. Okay. Regarding data mix, while we would like to be able to have like an equal proportion of all the various languages that we train for in Southeast Asia, unfortunately, some we have less data than we would like than others. So, for instance, for Mandarin, there's quite a bit, right? For Vietnamese, for Indonesian, for Thai, there's quite a bit. But then for Malay, Tamil, Tagalog, Burmese, Lao, Khmer, and so on, we don't have that much. So it's as much as we can get, right? After we verify the quality, right? So we try to maintain a percentage, or rather a proportion of about 40% for English. And this English data includes English data that's like so-called your global English data, but also a lot of the Southeast Asian contexts are inside. And we also have about 10% code. Now, the reason for having the English data and the code data is because a lot of the your global knowledge, if you will, and even sometimes like your regional knowledge, the high quality versions of it is still locked behind English. I guess a very quick example of this would be if you go to Wikipedia, right, and you check the information available for any wiki page that's in English. Likely it's going to be a lot more than for some native language. Even if it has that kind of data, likely it will be less or it might be non-existent, in fact, right? Of course, the reverse might also hold true. There might be some pages where you have it in the native language, but not in the English language. But these are few and far between. A lot of the good knowledge and data is actually still locked behind English. So without English, is actually your model will lose out on a lot of that core knowledge that it should have. And code, we find to be very important to include because it really helps the model understand structure. So it's able to understand long distance dependencies. It's actually able to reason better when you include code data. But of course, it has to be of a high quality as well, right? Okay, so actually, if you're looking at the continued pre-training, it looks rather straightforward, right? You have a warm-up phase, and the warm-up phase has to be aggressive enough that your model can actually jump over the initial hurdle, and you're actually able to help your model to start adapting to the domains that it needs to adapt to. And then after that, you have your cooldown phase and you're needing to zero. But actually, in all of this, there are many different things that you can try, right? There's replay data, right? You can try many different parts, even with the warm-up phase. You can try curriculum learning. You can try many different kinds of techniques. You might even want to consider merging when you're doing your cooldown phase and so on. So there's a lot of different techniques that people have been investigating, but there's still a lot on the table, right? Even for us. Okay. So now I will talk a bit about the evaluations component, right? For us, we actually wanted to have a Southeast Asian benchmark because when we first started, I think a little bit before ChatGPT came into the scene, we were already worried about the state of benchmarks for non-English languages, right? And then when ChatGPT came along, the claim was that it can interact with users in natural language and it's also multilingual. So that's a huge claim. And we actually didn't think that ChatGPT was really that adequate for the Southeast Asian languages. But without the correct benchmarks that we could point to, we are not actually able to see where the gaps really are or be able to tell people where the gaps really are, right? So we wanted to build the benchmark for languages such as like Filipino, Malay, Burmese, Tamil, Thai, Vietnamese, Indonesian, and so on, right? So we also wanted to make sure that in making these benchmarks, we actually do have native linguistic representation. And this means that we cannot only rely on machine translation. Machine translation maybe gives you your first pass right? But you need a lot of human verification, human validation, and a lot of reworking. And sometimes you might need your human annotators to really help you to create the data as well, right? So not just linguistic representation, we also want to make sure that the culture is correctly represented, right? And this is point 3. Because a lot of times, like for example, if you look at MMLU, right? Yes, it's a knowledge benchmark, but a lot of it actually is from a Western or even a more US perspective. For example, if you look at their law data set, right? Actually, a lot of it reflects US law. If you look at the history or the geography, a lot of it reflects US history, US geography. So this doesn't apply, right, to Southeast Asia. We would need to have these types of cultural representations for the region. So in doing all of this, we also want to make sure that the benchmark is consolidated. That's why we want to think of SEA-HELM as an evaluation suite, right? We want our data sets to be integrated, and I'll give a quick quick few screenshots to show what we mean by having like an integrated benchmark. Okay, so I'll go a little bit deeper into how we tackle each of these parts. So the first part, lack of the Southeast Asian benchmarks. So as I mentioned, we need help from the native speakers. We need to have different groups of native speakers, right, for the various languages. And here's an example, right? Oh, wait, there's challenge 2 as well that goes together with challenge 1. So the native linguistic representation, right? So here are 2 examples of the benchmarks that we really had to heavily involve the native speakers, right? A C version of instruction following evaluation, IF-eval, and a C version of multi-turn bench, MT bench, right? And another one is actually our linguistic diagnostics, which we call Lindsay. And this is really built from scratch with the native speakers of Tamil and Indonesian. It's a lot of work. I will only show an example, in the interest of time, I'll only show an example from CIF-eval. So here, do pay attention to the bolded parts, right? Now, you see that in the English version, it mentions ECB, right? But we want it to be more relevant to Southeast Asia. So instead, we change it to ASEAN, which is basically the Association of Southeast Asian Nations, right? And this is, and we're talking about the ASEAN Charter, which is a lot more relevant for the Southeast Asian region, right? So this is just a very quick example of how we do the localization of the data set, but there can be other things. So for example, it might say like, start every sentence with a capital A, which works in English, but in languages like Tamil, in Thai, you don't have capital A's, right? You don't have uppercase A's. So instead, we had to localize it. Maybe we have to say like, okay, use the native numeral 5 or something, right? So something that actually would make sense for that language, for that script, right? And of course, this also applies to our empty bench and all the other data sets where relevant. Okay, so for cultural representation as well, actually, we had to do a lot of work with the native speakers to build out this data set because we really want it to be representative, right? So we actually have colleagues from all over Southeast Asia. We have one colleague who is from the Philippines, from Manila, and he went back to Manila to set up focus groups so that he could have these discussions with different groups of speakers, and they identified important cultural issues, right, that they think are representative of like, what an average Filipino would be more concerned with, right? As you might imagine, those would differ from what an average Singaporean or what an average Vietnamese person might be more concerned with on a day-to-day basis, right? And the idea behind having such benchmarks is that we want to test, right, whether models, given a particular cultural context, given a particular cultural situation, whether they are able to choose a correct set of actions that roughly reflect what an average Filipino person, what an average Vietnamese person, and so on might do, right? That's the philosophy behind this data set. So here's an example, right? I'm 9 years old. I'm at a family reunion, right? My grandmother extended her hand to me. What should I do, right? Now, if it's in a Western context, you might say, okay, shake hands with your grandmother, right? That's polite. But actually, you wouldn't do that in Filipino society. What you would do is you would take a hand and place it against your forehead for a mano, right? So it's it's about what really is the set of appropriate actions in that cultural context, in that given the social norms and so on. Yeah. So now I'm going to talk a bit about the consolidation of these benchmarks. So we have to taxonomize. We have to basically pick and choose, right? And of course, this is not exhaustive in any sense, because as models improve, so will their capabilities and so will their ability to handle tasks in different domains. But for now, we try to taxonomize the tasks in a way that we think is roughly diverse enough and comprehensive enough, right? And we also include English tasks actually, other than just like the data sets that are in those native languages, because we want to make sure that in training Sea Lion for the Southeast Asian languages to support the Southeast Asian languages, we are still able to have a model that is capable in English, right? Because as I mentioned, a lot of those core knowledge, core capabilities, you still require English. So we have to make sure that we don't cause catastrophic forgetting in our models. So here's a rough taxonomy. Actually, I think we've already slightly updated it. But generally speaking, we try to be comprehensive when we think about how we want to evaluate per language, right? And across languages. So we have quite a bunch of Southeast Asian tasks. Actually, this has also expanded now, but this is just a rough idea of how we have been trying to approach this, right? I will skip this because I've already mentioned it. And just to note, actually, our English data sets have been updated a little bit. But you can have a look at the website later. So, okay, I will talk a little bit about some of the more methodical parts of evaluation as well. We think this is a very important piece of the evaluation work too, especially when it comes to evaluating the generative capabilities of LLMs these days, right? So typically people might think, okay, we just set temperature to 0 and we get a deterministic response, right? And then you can do just one run and you will get a set of responses by doing just that one run, right? The problem is it's actually not deterministic, even if you're running at temperature 0. Depending on the setup, depending on how you are inferencing the models, the responses will differ, right? So it's not actually, and it's also not reflective of how users would use models in the real world, because nobody is going to specifically say, okay, I'm always going to have temperature 0 whenever I use the model, especially nowadays with like agentic users, with agentic use cases, people wouldn't set temperature to 0 because they need the model to be able to reason and so on, right? So instead, what we are doing is we use the defaults that the model developers provide, right? So as an example, if the Llama 3.370B says temperature should be at 0.6, top P is 0.9, we follow those defaults, right? Now, this means that we need to do more than one run. And we've done some experiments and we choose 8 runs because we see that, okay, it roughly stabilizes, right? The standard error diminishes after 8 runs. And we actually tried up to 30 to make sure that this makes sense for us, right? So we have a trade-off between cost reduction and standard error. So we settled on 8 in the end. And actually doing it this way also gives us the ability to calculate a confidence interval, right, over the 8 runs. So how we weight the scores is we look at the competency scores for each language and we average it to a task score, right? So I showed the taxonomy just now. So when you look at a task score, it's an average of the various data sets under that task, right? And the language score is the average of the competency scores within the language, right? And then you also get to see like an overall SEA-HELM score, but this is kind of like an average of averages. It just gives you a rough indication, right? So we have a 95% confidence interval. So here is a screenshot. Actually, you can see this if you go to the leaderboard, right? So leaderboard, you can just go to c-lion.ai and then there's a blog post there, and you can also get a link to try out the free APIs, and you can also get a link to the screenshot, the leaderboard from there. Here are some screenshots, right? This is the C overall score, what you might see, but we are updating, we are still adding some models in, so this may change. this is the overall score, and you can toggle. You want like less than 10B models, you want less than 200B models, you want instruct models, reasoning models, and so on. You can also look at a particular model's score. So if you, for example, if you select Thai, then you can see like what's the average score for Thai, right? So you can zoom in a little bit more. And you can see like, okay, where do the models stand if I'm looking specifically at Thai? And then you can zoom in a little bit more even, and you can see, okay, I know roughly what the models, how the models perform for this language. I want to see like specifically for each competency, for each task, right? How are the models doing? And you can do this by, when you scroll down a little bit, you get to see like, okay, for instruction following, this is the score. If you click on knowledge, then you get to see like, okay, for knowledge, this is the score and so on, right? So now I'll talk a little bit about our version 4.5 as well. With 4.5, we didn't actually do continued pre-training. What we did instead was we really focused a lot on using some customized distillation techniques to train the models. And this allowed us to really distill from much more powerful, much larger models, right? And then we use these larger models to pack in a lot more into sea lion so that given its size, it's actually able to perform that much better, right? And for this 4.5, we actually trained Gemma 4 E2B and Quen 3.6 27B, right? And with a specific focus as well on multimodal agentic use cases, right, across Southeast Asia's languages and cultures. We also introduced a speculative decoder, right, which I will talk a little bit more. Generally speaking, this speculative decoder really allows for the model to output tokens much faster, right? So just to quickly go through, basically the speculative decoder is, as I think some of you at least will be familiar with, it's a drafter model, right? So it drafts the tokens, and then the main model will verify, and if the tokens are accepted, then there's a speed up, right? If there needs to be a regeneration, actually, then the main model will just generate the tokens by itself. So this means that there may not be a speed up, but it's a lossless process. So basically, your speculative decoder will only accelerate, but it will never affect the actual output of the model, right? One special thing about our speculative decoder is that it is not actually sequentially predicting the tokens. What we are doing here is we are looking at predicting a block of tokens all at once. So here is a quick table, right? With with the baseline, meaning with the Quen Sea Lion v4.5, with the multi-token prediction turned off, right? That's your baseline. And then with the multi-token prediction turned on, you get a bit of a speed up. You see that for the English tasks, there's about a 2x speed up. And then for the other Southeast Asian languages, it's a little bit less than that, right? Our spec decoder is actually based on DFlash by ZLab. And what they have done is they've optimized a block diffusion model to be a speculative decoder, and it works pretty well for English. So you see that you get more speed up for English tasks. But then for the Southeast Asian languages, there actually is less speed up than even Quen's MTP, right? So what we have done is we've optimized their DFlash so that the English task as well as the multilingual task, there actually is more of a speed up, right? So let's zoom into Burmese a little bit. I hope I can play this video. Okay, so the bottom is with our speculative decoder, and the top is the baseline, meaning without the speculative decoder. So what you see is that the token per second is actually much higher, right? For the one with the speculative decoder, and it's already done, right? Whereas the baseline one is much lower, and it's still, right now it's still generating, right? It takes actually more than 30 seconds for it to finish the generation, right? And this is important because for many tokenizers, right, for the LLMs, they are efficient for English and maybe like some of the Latin scripts, right? But they become far more inefficient once you move into the realm of non-Latin scripts. So like Burmese, that's why we're using Burmese as an example. And in fact, like you could maybe be looking at maybe like 10, 20 tokens, or sorry, I should say like maybe like 5 or 10 times more tokens to represent the same word in English versus like in Burmese or so on. And I'm sure this is a problem that we will also face in a lot of the African languages. And yeah, actually, this brings me to the end of the presentation. I hope I'm doing okay on time. I want to leave more time for discussion. Should we look at I think there's some questions in the chat.
Hey,
Yeah.
hi, Jian Gang. I think this was awesome. Thank you for this. And then, yes, we'll open it up for questions for everybody on here. You can raise your hand if you want to ask a question, then I will acknowledge you and then you can unmute and then ask your question. But while we're waiting for that, and then if you want to ask via the chat, you can also put up something in the chat. Thank you, William. He's already been answering some questions that are in this space. One, I like, and thanks for also covering like, the parts about the tokenizers and also what you guys have done as you've gone through the different variations of these models over time. I guess maybe let's go on the opposite side, where necessarily somebody has let's say there's a small, medium, and then I will unfortunately use your infrastructure as a large. And then let's go to a small kind of infrastructure. People might have, what is it, L4s, T4s, A6000s, maybe one or two at a time. We also have, for example, a NVIDIA Spark now that's provided by NVIDIA as a grant. What can people think about doing in terms of how you come to the continued either pre-training or the supervised fine-tuning, and how then might be the best way to keep track at those smaller scales? Then you can think maybe about a medium as being somewhere halfway between your large and then the very small in a space, and then what would change if that was the perspective. So I'm a person of practicalities, because I think that you will see a lot of the questions that are coming here is because people are trying these things. So giving some heuristics will be very important. Yeah. And then after that, I'll start going through the questions that are coming through.
William, do you want me to answer this?
Go
this
ahead.
part?
Yeah, go ahead, Jian Gang. Yeah.
So I think depending on the type of training that you want to do, because for us, right, CPT is unfortunately, I think, quite an expensive process. And the reason for this mainly is because in order to really kind of like shift the model weights effectively to adapt to a different domain, you need to have enough data, right? And honestly, it's not just about the quantity, right? Because if it's data that the model has already seen before, which you may or may not know, even if you have a lot of that data, you likely will just cause a lot of forgetting in the model for not that much gain, right? So in some sense, you really need to make sure that the data is high quality, but you also need to have enough of it. So for many people, CPT is way too costly, right? In terms of pre-processing of the data and also in the actual training itself, right? That said, post-training is a lot cheaper, right? And for us, even though we do, for example, like we do full fine-tuning, right? But that's not necessarily something that you need to always do, especially if you are at the early stages of the research, of the experiments. You can do, for example, like LoRa, which will be a lot cheaper, right? So these will be, it will still take time, right? Because if for example, you're running on L40s and so on, then of course, naturally, it will take more GPU hours. But there are ways to have more lossier training, but it will be easier in some sense, right? As in, it won't take as many GPU hours, and maybe it will cost like fewer GPUs and so on. It's just that you do need to bear in mind that the quality of the data is still really important, right? Especially if you expect that the model is pretty good already for that given language, then maybe you need to be putting in that much more high quality data in order to see more. But if it is something that the model actually is not that great in, you might actually be able to have data that is already, relatively speaking, like high quality, right? And the model can learn a lot from, because it doesn't, not that much of it is represented in the model itself, right? But I think hardware issues are, it's hard to get around them without having to make some kind of trade-off in terms of how you want to toggle with your training parameters, so to speak.
And I want to probably add on to this, right? A little bit higher level here. I feel like, yes, it's very important to understand what compute is available for us, but there are equally important is also to know what is available out there. For example, if your language is already supported well to some degree by the base model, the tokenizer for that language exists, then fine tuning makes sense. Now, if the base model doesn't even know the language at all, doing fine tuning will not be very useful. Right? It's going to be a waste of effort, right? So I think establishing the needs first is important, and then map it to the compute that situations that we have, right? So, for example, in a situation where we can do fine tuning, there is a model, then you can play a little bit with the size of the model, right? If you have constraint in the compute, we can go with a little bit smaller models and do fine tuning, right? But if you can do a little bit, you have a little bit more compute, there can be a bit of mid-training happening, right? In the situation where the model is really in extreme situations where the model is not even ready to be fine-tuned, and then the compute is not there, my suggestion is actually to build the evaluation, right? To build evaluation first, because that way, whoever, it opens up the possibility somebody who happens to have the resource to kind of at least build a model and have a yardstick to follow, right? Rather than doing it blindly. And then, in the future, when there's a possible more resources available, then suddenly it becomes possible to do it without having to build the evaluation. So those are some practical advices.
Okay, no, thanks a lot. I think that's a lot to take in, and then we'll yeah, we'll think. Samuel, you can go ahead before I start going into some of the chat.
Yes, thank you.
Thanks, Samuel.
Yeah, I had a couple of questions. Yeah, I'm
Samuel, I might know you, but maybe if you introduce yourself and where you're from, that would be great.
Okay.
Yeah.
Yes, I'm Samuel Rutunda. I'm from Rwanda. And yeah, I work at Digital Muganda, but I'm also part of different communities in Rwanda and across Africa, where I think part of understanding how to train these models have been coming up. And I had a couple of questions. So the first one is on the data sets. Like, what's the minimum amount of data needed to be able to train, to be able for a language to be included in the training of the data set? And then the other one is the type of data sets included, especially for the low resource languages, because on our side, we found that most of the data online are news or religious text. And even when you train, you find they are biased towards those. And then I think you mentioned something on translation. On our side, we realized that the bigger models, the frontier models, they tend to know better Kinyarwanda. And we've been thinking, should we then translate or use those models to generate data sets? And then the last question is on speculative decoder. Yeah, you mentioned that it improved the speed, but does it also does it affect the quality when you use it, or as opposed to when you don't use it?
Yeah. Thanks, Samuel. I probably have
Just
that.
sorry
Yeah,
to
go ahead.
disturb. Maybe Jian Gang, if you might want to just stop sharing your screen, and then yeah, it'll just make it a little bit more
Oh,
easy.
okay.
Yeah.
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 Okay. Cool. Yeah. Go
Thanks,
ahead.
Samuel. Yeah, I answer a couple of the points and then I'll leave a few to Chen Kang. So, for example, I guess it depends on the language, but I find that somewhere closer to 10 billion tokens tend to show a little bit more improvement in terms of the, when you do a pre-training or continued pre-training. So probably target around that. I mean, of course, the more the merrier. So that's one. Um, I think I will leave the contents to Chen Kang to answer. But in one country or two countries, yeah, in Laos and in Cambodia, I couldn't get anywhere close to 10 billion tokens. So what I did was exactly like what you shared, right? So in fact, we built machine translation models and also audio transcription, speech to text, ASR kind of model to transcribe some text because sometimes the data are available in audio or sometimes the data are available in other languages. We important thing is that yes, we can basically generate more data through these new two tools, and these two tools they don't really need a lot of data if you rely on certain architecture. But very, very important to involve the community here because when you translate, you will lose a little bit of the cultural nuances. Transcription also, potentially there may be certain things that needs to be validated. So it's very important to have the community to kind of what do you call it, shepherd the whole development of token building. When you get to up to a certain stage, maybe if you don't get 10 billion, you get like 5 billion and so on. I mean, if you have the resources, you can start actually doing some training. The model will not be great, but if you have the community, you can put it there as an inference engine, and then tell the community if it is large enough that we put it there so that people can give feedback to it, and then those feedback will be used to generate even more tokens. Without the community in this situation, it's going to be very, very difficult to basically regardless of whatever tools you have, right? So maybe Chen Tan, do you want to address the what kind of data and also the speculative decoder?
Yeah. So actually, I guess one key thing to note is that even for English, right, I don't think anybody is yet seeing a saturation point for how much data you can train your models on, right? Which is to say that actually, as much high quality data as you can get, especially for the languages that you want to train your model on, I don't think you'll run into the problem of like having saturation, so to speak. Now, one thing to note though is if let's say you're trying to train on more than one language, so say you need your model to be multilingual, kind of like in the case of Sea Lion, right? We do try to balance out the proportion, if only because we don't want there to be overrepresentation of a particular language. I'll give you an example of this, right? So with 4.5, we actually tried to train the model on reasoning, the thinking tokens as well, right? So with your thinking models, they actually have a thinking block before they generate the actual response, right? So we actually wanted to train on the thinking block too, but because it was mostly in English, right? What happened in the end was that the model actually had an overrepresentation of English. So everything else just got overwhelmed by English, right? So having this proportion there is actually really important. Um, yeah, and if you're thinking about post-training, right? Let's say SFT or something, potentially you could get away with maybe 500,000 instruction pairs or 1 million instruction pairs. Maybe 500,000 if they're really high quality, right? 1 million. A lot of people tell us that's too much, but we're not too sure about those numbers yet. Yeah, definitely. You can already see effects with less, right? Depending on what you're trying to get the model to do. Okay. So that actually answers a little bit on the type of data part, right? So your use case is really important when you're thinking about what you need your model to do. Do you need your model to be a translation model? Do you need your model to be, for example, really good at understanding instructions and following instructions, right? So, or if you need your model to output in a specific kind of format, right? So there are certain things that you need to bear in mind when trying to design your data sets for those purposes, but also, again, the evaluations are really important, right? Because if you know that you need your model to perform a certain type of task really well, if you know that you need your model to adhere to a certain type of format really well, you definitely will want to have the evals for that so that you can track as a baseline where does the model stand before I do anything. When I actually start training the model in any kind of way, do I actually cause any kind of forgetting or degradation unintentionally? Because with SFT really is like a blunt hammer, right? So it will cause a lot of forgetting. It will cause a lot of changes in the model's behavior, sometimes unexpected, right? Or I should say, most of the time, unexpected behaviors will emerge. So being able to see where that happens is really important, right? And on the speculative decoder side, it is lossless again. Um, for the speculative decoder, it has to be paired with the model, the main model that it is supposed to give that boost for, right? And precisely why it is lossless is because it can only be paired with that model, right? So essentially, what the speculative decoder does is it generally will follow the same probability distribution of the tokens as the main model, right? And when it does, it will predict the same tokens as what the main model would predict anyway, and then the main model can just kind of like generate them more quickly. But in the event that the main model, as it verifies the tokens that have been predicted by the drafter model, the speculative decoder, it finds that, hey, this model isn't right. It doesn't actually accept that token prediction. It will regenerate on its own. So that's where you actually won't get to see the speed up anymore because the model has to do its own generation or less of a speed up. But because of that, again, it's lossless because the model's final output is not actually affected in any way by what the drafter model or the speculative decoder generates. Yeah.
Maybe I just want to also add, the number of tokens is also affected by whether you have a neighboring language exist or not. Like for example, if you have language that's from the same family, potentially your number of tokens required a little bit smaller than if you have a totally, not really, there's no related language available in the model itself. Yeah.
Although sometimes, like with cross-lingual transfer, it's a bit fickle. Sometimes even on unrelated language families, you still see that there's a bit of cross-lingual transfer. So it's kind of interesting. Yeah.
Yeah, there's a lot of research studies to be done there. So let's look at some of the questions. Because I will just.
Sure. Thanks, William. Okay, so there was a couple. Okay, I'll come back to Samuel's one later. Somebody has highlighted that they're having the same problem in using Burmese that doesn't have Latin script, and maybe if there's any other notes about non-Latin scripts, that would be great. And there was one then about how did you create the data quality buckets and what was manual and what was automatic. I know Jian Gang might have answered in the chat, but then it would be great also for discussion and if it might bring up more questions because of that before. Yeah. So I'll keep it to that now, and then I'll come to you now and Siani and Abebe in a little bit. Yeah.
Yeah. So I think same here in pretty much all the actually majority of the Southeast Asian languages don't have Latin script, right? So in the early days, that's one of the reasons why actually our early version of the Sea Lion, the first version, part of the reasons why we pre-trained from scratch was because there's no tokenizer for these languages. So we actually had to train our own tokenizer at that time. Only when we found that there is a little bit more support for a tokenizer did we kind of consider moving to CPT, or doing mid-training. I think for your case, maybe it's good to do a little bit of assessment of if there's any existing tokenizers or models that come with the tokenizer that support your script. If there is, then it's good news. If not, then unfortunately we have to probably train one, and then then we go back to similar situation where we started with SEA-HELM version 1, where we have to do a pre-train. Start with something small first. Yeah. Anything to add, Jian Gang, on the buckets, quality buckets question?
Let me think about what I haven't mentioned for that yet. Yeah, it's so in the process of trying to do this set up the heuristic rules for each language, right? We actually did train a small tokenizer per language. So this is separate from the tokenizer for the main model, right? But the idea here is that we need to have something individual or particular to that language so that we can better account for whatever the data quality would have to look like. So for us, right, if we wanted to really have a separate tokenizer or train a new tokenizer for the sea lion models, meaning we don't use the tokenizers that from Gemma or from Quen, right? That could also be possible, but as William mentioned, like that will take a separate effort, and we will have to really do the research on that to make sure that it works properly. Fortunately for us, the support from the Gemma models and from the Quen models are already somewhat there. Previously, with the previous version of the Quen models, Quen 3 series, we saw that for some of the languages like Burmese, Tamil, there was a bit less support. For some of the languages like Burmese, Tamil, I think I mentioned that already. Like the tokens were not that great. But then with 3.5, actually, it improved a bit. So we're glad to see that.
I love to think that we made enough noise for the Google or whoever to listen to us and start support. Yeah, we have to make noise.
Yes.
Yeah. Okay, we move on to the subsequent questions.
Yes. Okay. So we've got we had from Neo, you mentioned that human involvement in the evaluation pipeline for the two tasks. Please walk us through how that looks like in practice, how annotators are recruited, trained, and guidelines for rubrics to work with, and of that methodology that is document what might be there publicly, so that people can replicate. And then that's Neo, and then Siani says, which translation tools models were used and why? By any chance, then did you also create any synthetic data?
Okay, I think these are all up your alley, Jian Gang. I think you were probably involved in the actual designing of rubrics and the data.
Yeah,
Go
back
ahead.
in the day. So we were hosted by the National University of Singapore. Now we're hosted by Nanyang Technological University. I bring this up because being hosted by an educational institution gives us access to certain groups of speakers, but it also kind of limits our access a little bit. So it limits us in the sense that there are some restrictions around who we might be able to recruit, who we might be able to hire to do this annotation process, right? So it was easier, for instance, for us to hire students, not necessarily only from NUS or from NTU, but various universities, various public universities in Singapore. And then we could also say like, hey, we need to hire students who can speak, maybe like Filipino natively or Vietnamese, Tamil, Burmese natively, and so on. And we actually specify, right, in the recruitment poster, so to speak, that they have to be native speakers of these languages. Here are some of the examples of the kinds of tasks that they will need to do, right? Things like verifying the quality of the data. Maybe they will also need to create data in some cases and so on, right? So that's just kind of like a high level introduction for people who then maybe it would interest them to sign up. And for the particular task, like in this case, we are talking about let's say, for example, the quality filtering task, right? Where they have to look at, okay, how do I toggle the values, whether the retained and the discarded make sense or not. They actually are briefed on those tasks to tell them like, okay, this is what this task is about. Actually, this is really to help to improve the CLI model in this way. You're supposed to be doing this. And we really make it such that even if they don't know that much about Gen AI even. As long as they kind of understand what they're doing, they will be able to perform the task, right? And of course, if let's say they have certain concerns about how the task is being done, like if they think that like it's just not like they don't understand or something just seems off, they can always tell us, right? We have native speakers as well for those
Yeah,
languages.
I think on the broader context is that besides we engage the students and quality controllers, we also have native speakers joining us like a full-timer. We try our best to bring the whole countries represented in our team. And also we build partnerships. I cannot overemphasize this. It's important to have partnership. In every country that we work with, we have a research partner there. So they provide a little bit more guidance, like a broader support on the validations besides the team that we hire to work on the quality control. So I think very, very important. This cannot be done without these partnerships.
Yes, yes. And yeah, the community is really, really important. Is sometimes the reason why we're able to do any of this really is because we have the community support. Even if we had the annotators, right? If we didn't have anybody from the team who understood the language, it would still not be very useful for us. We would not be able to design the guidelines, we would not be able to understand any of what they're doing. And with the community, same thing. Yeah.
Yeah. So we move on to the next question, which is the translation tools models we use. So we actually, because the reason why we need the translation is because we don't have any model that's working well on that, right? So it's almost all the time you cannot just use Google Translate for it. You have to train your own model, but you have to collect that parallel corpus. And then don't go with don't use an LLM to don't train an LLM to do the translation. Train a smaller encoder decoder model, a classical neural machine translation using this data to help you generate more data, right? And also in this manner, it's easier also for you to evaluate because the encoder and decoder seems to be a little bit more well behaved in terms of the output compared to a decoder only. So to answer that question, and then on the syntactic data, Jian Gang, again, back to you. This is your area of expertise.
We do actually use a lot of synthetic data to help to augment what we have, right? Because there's only so much natural data out there, especially for some of the languages like Lao, Khmer. It's very, very little data that's available. So synthetic data generation, while not ideal most of the time, for obvious reasons, is a way for us to at least kind of get the quantity there, right? With the quantity of data, and then if we have the native speakers who are able to help provide some feedback on the quality of the data, we think that is kind of the way forward in a sense, because we cannot expect humans to be able to always be able to generate high quality data at such volume that can actually affect the model training. And the reality of it is that with what people expect models to be able to do, we cannot always rely on having just the human generated but very high quality data, because we would take a very long time to collect the data and it will be extremely costly. Yeah.
Okay. Yes. There was a question from Abebe on the same tokenization for all languages. This might be more on core choices. And then I wondered if Idris, you might have any questions for the AI Singapore team. Okay, but yeah, maybe we can for now ask that question about the tokenizations across different languages and what that might mean.
Go ahead, Jian Gang.
Yeah. I'm just thinking. So, okay, the long and
I guess
short
it
of it.
depends on different versions of the sea lion. Yeah.
Yes, exactly. Yeah, the
Yeah.
long and short of it is we don't actually change the tokenizer when we do the model training, right? So what we are doing is we are kind of adapting the models that we train on. So for example, the Gemma model or the Quan models, right? We are adapting them to be to give like more informative, more detailed, more culturally rich responses for any of the C languages that we train on. But we do not actually train the tokenizer separately. So the tokenizer is exactly the same, right? Which means that we inherit all of the inefficiencies or efficiencies of that tokenizer. If you're curious, the Gemma tokenizer is really good, right? It's really, really multilingual. The Quen tokenizer a bit less so, but as I mentioned, it's improving. Yeah.
Okay. Casper, do you want to ask your questions? I know there was a couple of them. Maybe ask 2 questions by unmuting.
Okay. So I saw that you mentioned that you used Quen. I was wondering, like, first question is, what are some of the factors to consider when selecting the model that you're gonna start with, be it for fine-tuning or pre-training? And then the second question was, let's say in a low resource setting, like where we are at, what would you consider? Let's say, for example, in Africa, we've got so many languages, and if we were trying to have an impact on a lot of the languages, what would you give advice on in terms of like maybe going wide and covering more languages, but then of course each language will have much less resources, or maybe just focusing on a few target languages, which you might be able to go a bit deeper on in terms of resource allocation?
Yeah, maybe I try. Thanks, Casper. I address some of the points here. A couple of factors. For us, surprisingly, number one is license. We can only work with models that have very permissive license because our goal is to empower the community. If the license of the models restrict us in some way, non-commercial and so on and so on, usually we deprioritize. So I think that's super critical for us. The second is also tokenizer, as mentioned before. We like in the past, I think we went with Gemma to some degree because there were more support for the tokenizers. We did a little bit of testing, right, compared to some others. We also look at the sizes that's available on the models. Say our target is to have a range of smaller, medium, and large models, then we only choose those models that have those sizes as the base instead of I think I recall in the beginning that's why we chose Llama because the Llama actually had the 70 billion. We want to have a big one, and Gemma was up to 27 billion. We also look at the architecture. Mixture of experts for us in the beginning was quite tough to work with. So I think at that time we look at the dense model more. But, even though I think Jian Gang now is probably looking at the MOE a little bit more. I want to trigger this point. Later, Jian Gang can share with you a little bit more about the struggle that we had with fine-tuning some models and how it impacted the way we chose, the selection. We will come back to that. On point number 2, the strategy that we approach is like this. Again, I will keep emphasizing the importance of collaboration. You cannot do this alone, right? So in Southeast Asia, we have about 1,000 languages. But we only have about a dozen or so national languages. The way we work was actually to support the national languages first as a sea lion effort. Why? Because that gives us access to every single country in the region. And what's interesting is that the moment we support one language in a country, like for example, Indonesia has like 700 languages, right? So we support Indonesian language, and then we manage to kind of attract the interest of actually the biggest technology company in Indonesia to basically work with us building open source models together using whatever we have learned in the Sea Lion team as their base, so they don't have to repeat all the painful process that we did before. Give them a head start. And because of that, they could actually allocate their energy to support beyond the Indonesian national languages and support Indonesian national language and support other Indonesian languages like Balinese and Javanese and so on. By the way, they also have more access to the tokens there because they're closer to the community. So in that way, we kind of multiply our effort by having these partners. We are doing the same right now with the Philippines, right, where they have many languages. We have the Tagalog to support, but then they can propagate this to beyond Tagalog and so on, right? If we don't do it in this way, it will be very, very painful. So hopefully, it can be replicated, similarly. So Jian Gang, you want to talk a little bit about the fine tuning?
Yeah. So before that, right, one of the things that does help to make us make a decision as well is actually SEA-HELM, right? And we use SEA-HELM to get a rough gauge of like, okay, what are some of the more multilingual languages, some of the more multilingual models for the languages that we are benchmarking. And we generally do see that, Gemma is very multilingual. It's very strong. Quen is also, maybe it's a little bit less multilingual than Gemma, right? But it's still a popular model. It's still a strong model, right? And especially we also see that, there's a lot of people in the community who really think that it's a model that they're able to deploy, right? Even with slightly more limited hardware, depending on where you're from. But they can use it for various use cases, right? Now, the reason why we want to have different architectures is, William alluded to this, is because like some architectures have been easier to work with than others. One thing that we've noticed with the Quen models, Quen 3, Quen 3.5, 3.6, is that it's actually somewhat easier to train, right? Like the loss curves, the grad norms that look smoother, we're actually able to see that the models are improving on SEA-HELM, for instance, when we do the training. Compared to Gemma, where yes, there is still gain, but very much like a lot less, right? And it's likely because actually the Gemma models, they derivative of the Gemini models, right, which are really powerful models. They've been trained on a lot of very multilingual, high quality data already. So likely that the kind of data that we can further train the Gemma models with is already data that the Gemini and the Gemma models have seen before. And then that actually is less likely to move the weights as much or to really like make the models perform that much better. So as a baseline, you already see that the Gemma models are very strong, right? I think you saw from the screenshot just now, the Gemma 31B Gemma 431B is already really strong, right? Then to make it improve even more is difficult, right? But this is also a result of, or rather, this is something you expect to see, right? If your benchmarks are correct, you should really see models that are performing really well start to taper off at the top, right? If everything just immediately saturates, then your benchmarks are not great. Yeah. So yeah, long story short, we want to give people different options. Even for ourselves, we want to give ourselves different options because we've come to realize that different models have very different behaviors when you try to train them. Yeah.
Yeah. Maybe we can continue with question number 3 and 4, Casper.
Yeah, go ahead, Casper. Yeah. And then, Casper, go ahead. And yeah.
Oh, okay. So the question is basically as it says in the chat. So, okay, so like you mentioned that at the bare minimum of 5 billion tokens, this was per language, right?
Yeah, per language.
Yeah. So in that case, let's say for example, you mentioned that Gemma is already quite strong, and let's say if you, in the absence of high quality data like that, so it would just make sense to focus more on maybe model alignment, in the way of supervised fine tuning instead of pre-training on a model like, let's say, Gemma, which is already quite strong.
So maybe I take this one first. I think if you find yourself still needing to do the continued pre-training, because the base model is for that particular language is still not that strong, then I would really not. I mean, we can try to fine tune, but typically, if the base is not there, the fine tuning is probably not going to bring you a lot, right? So I think we probably need to work some ways to bring the tokens up first and then do a little bit of continued pre-training to improve the performance of the base model on that language. I don't have like this is speculative, and Jian Gang, you feel free to disagree with me here. But in my mind, if you don't have enough 5 billion tokens, because every token is actually quite expensive, it actually adds on to your training cost. If you don't have it, you probably want to keep it first in the next round until you have substantial. Although in some corner cases where again there's related language existing in the mix, then you may want to include it, hoping that there's some kind of cross-lingual transfer happening there. So that's probably my answer to question number 3. I see Jian Gang nodding, so yeah, I don't know.
I'll add on a little bit. Definitely, it will help, right? Like if you're trying to train for a particular language, it does help to have tokens from other languages that maybe are like from the same region or share similar cultures or from the same language family and so on. It usually will help. Another thing is that actually recently there's been a lot of research that's looking at including instruction pair data, right? Like previously you would think that, okay, for CPT or for pre-training, what are pre-training, right? I'm talking about like pre-training, not the mid-training. So CPT is for mid-training, right? For the mid-training part, what you want to do is to have like the raw data, right? So like you have your internet snapshots and so on. But there's been a lot of research that actually has explored, right? Looking at including instruction pairs, right? Data that's in the form of instruction pairs into your mid-training as well. If you find that for raw tokens, you're not able to get as many as you would like, but you have some way to synthetically generate instructions, that can also bolster your token budget a little bit, right? But of course, it's still a very costly endeavor. Yeah.
So maybe I just answer the 4th question. How much automation, I suppose, can you apply in the data processing pipeline? Is it mainly manual per language or one size fits all?
Yeah, and then just quickly a question there was, what challenges arise for annotating low resource languages with diverse dialects and cultures? And then the last one, MOEs, GLM models, how does SEA-HELM compare to those if resources were made available? Yeah, good. Those will be the last questions.
So for data processing pipeline, I think there will always be some form of manual works in the beginning, and then per language, and then the way we are trying to automate the process is by training things like CAN-LM and so on to take it forward, right? So we just do the manual work the first time. Deduplication, though, I think deduplication is mostly automatic, right? I think it is mostly automatic. So that's question 4. What challenges arise when annotating low resource languages with diverse dialects and cultures? Jian Gang, you wanna try this one?
Yeah, there's definitely a lot of, okay. Let's take Indonesia as kind of really the prime example of this when it comes to Southeast Asia. Indonesian as a language is not monolithic. The way that people speak Indonesian you can see William shaking his head, right? Indonesian sounds really, really different from one part of Indonesia to another, to the point where like some people, some native speakers will even say like, I cannot understand their Indonesian anymore, right? So it is a challenge. Right now, the main Indonesian dialect that we are working with is actually like Jakartan Indonesian, right? When you go to Javanese Indonesian, it will sound very different. Sometimes there's also a bit of code mixing, code switching happening. That is another issue, right? So a lot of these things, these are all challenges, right? We don't really have a good way of solving it, but we think that a good first step is being able to really acknowledge, identify that where these sources of variation might arise, that really does help you to better account for them. So one thing that we are thinking of would be like, if there comes a day where we have a strong enough community outreach for Indonesia, for example, we can have like different communities of speakers from different regions that are more or less representative, and then we can start to. But this also is an effort in itself, right? Being able to collect enough data from their region to have something that is going to actually affect the model training in a significant way. Yeah.
And I think just to not to make it too depressing, but just to keep it real, right? The moment you move to voice, then it's even it's even more complex with accents and so on. So just additional complexity. For cultures, exactly like what Jian Gang was mentioning. No way you can do it without the community locally, right? Because you cannot assume that right? And the diversity and the sensitivity surrounding it, especially when it's diverse, one local localities versus the others, you have to work with the communities there. Compared to MOEs, JLM, SEA-LION, yeah, I think SEA-LION can be improved if, you have the numbers, go ahead.
Okay. Our V4.5, this is on Southeast Asian languages, okay? Right? So we're talking about the native language, some of the native languages in Southeast Asia. So SEA-LION version 4.5, the Quen version, right, is a 27B model, is around 69.97 on the Southeast Asian average, right? Gemma 4, as I mentioned, the 31B is a very strong model, very multilingual model, 72.02. I think I am not 100% certain on this, but I think we are still awaiting some of the GLM, the larger GLM model results. They are, I think they're incoming. But so for example, like this one, this is the GLM 4.7 Flash, the 30B, right? So somewhat comparable, I guess, in terms of model size, but it's not as multilingual, right? And this is even if you compare it against, say, like the Quen 3.5 as a baseline, so already you can see that it's not as multilingual. So it really depends on the set of languages that you're looking at. It depends on the types of tasks that you've included. So for us, we know that the GLM series are really good, but for our use case, we probably would still want to start with like the Gemma models or the Quen series. Yeah, so you can see like the Gemma 4 E2B is also higher.
One thing to note also is that the positioning that we have is that we do not intend to compete with reasoning in English. I think you already have Claude, you already have ChatGPT, Kimi, JLM, all these are very, very good. We focus very much on, especially in the multi-agent world in the future, we can work with multiple models talking to each other. Our focus is to improve the regional capabilities of the models, of which I think in the case of GLM, they are not, specializing there. So, I think here we can complement the power of GLM in Chinese and in English. Can we use the GLM as a base to find? Of course, we can. Yeah, but that's again, go back to that decision. What kind of models architecture we want to choose as our base.
Yeah, one important thing to bear in mind is that even if a model is really powerful in English or maybe like in a few languages, that doesn't necessarily carry over to all the languages, right? And conversely, depending on your use case, even if the model doesn't always seem like it might be the best starting point, it may actually turn out to be that for your particular use case is good enough, right, so to speak, or it can actually be a good starting base. Yeah.
Yeah. Maybe just a quick reply to Rafia. Thank you very much for this. Yes, and that's the reason why I want to work with Bukoshi very closely. Yeah. So, I think whatever mistakes we made, hopefully you don't have to make it any, in the future, Bukoshi.
Yes, thank you. And in closing, I think it's not just us, what you had, and the reason the questions have been so much is that you actually have a lot of different teams from across the continent who are building LMs and LLMs at the moment. So we're very happy to have been able to host you guys and then get this. And yes, for everybody's context as we close, I know we're 1 minute over. We are working at the moment on a more Pan-African LLM. So we're trying to think about a lot of these decisions that have to be made, and there are so many. And we're testing out things, and we hope by the end of the year to have kind of a version 1, if not version 0.1, in this area. But then we're also interested in what you might be working on out there. So please do let us know, and we're trying to see how we can collaborate. I think we'll probably make an announcement in the Masakani Slack for people who might want to collaborate on a couple of the things that need to be done in between. So yeah, it's a lot in these spaces, but yeah. So thanks to William and Jian Gang, especially that it's late at night. We really appreciate it for taking the time. And yeah, we look forward to interacting maybe a few more times before the end of the year as this goes on. So
Thank you so much, Bukosi. Thank you so much, everybody. Safe flight, Bukosi. Yeah, I'll see you guys soon. Yeah, bye-bye.
Yeah, bye.
Thank you. Bye-bye.